We are giving this function 1 over x multiplied by x minus 1, and we want to find where's the local maximum and where's the local minimum. So again, first thing to determine where's a local maximum or minimum is first to find the critical point, and then second we will test for local maximum or minimum at that critical point. So for critical point we find the first derivative and equal that to 0, or we find where it's undefined. Notice that f of x here is a fraction, so we have to care about the domain of that function. So it's gonna be undefined when the bottom is 0. That's gonna be at x equal to 0 and x equal to 1. At these points, again, the functions are not defined. And therefore, these points are not in the domain of f of x. So we take the derivative first of our function. The function can be written as x multiplied by x minus 1 all to the power minus 1. Here, to take the derivative, we can use the chain rule. But first we can simplify. So what I'm gonna do, I'm gonna multiply the x to what inside the parentheses. So that's gonna be x squared minus x to the power minus 1. Now we are ready to find the first derivative. It's gonna be minus 1 and then x squared minus x to the minus 2. Then using the chain rule, it's gonna be 2x minus 1. Now it's gonna be 2x minus 1, and then we can bring this to the bottom. It's gonna be squared. Here notice that we have a negative sign in front, so we can get rid of that by multiplying to what's inside the parentheses. Now this is f prime of x. Now to find the critical point, it is where f prime of x is 0 or undefined. So where the function is undefined, so when they're at the bottom, x squared minus x equal to 0. Here we can factor the x. So what we'll have is, if we factor the x, gonna be x minus 1 equal to 0. Here gonna be x equal to 0 and x minus 1 is 0, which is just x plus 1. Now, these functions are actually not in the domain of our function f of x. Therefore, these points are not critical points. A critical point again has to be in the domain of the function, and then it is where the first derivative is equal to 0 or undefined. So two conditions to meet a critical point. So now we just go to where is the first derivative equal to 0. It's gonna be 0 when the top is 0. It's gonna be 2x equal to 1, and then x gonna be half. Now again, f prime of x is this function, and our critical point is x equal to half. Now we have to determine, is this a local maximum or minimum or either? So to do that, I'm gonna use the first derivative test. You can also use the second derivative, but I chose to do the first derivative test. So I draw a number line, and here I mark our point, x equal to half. Here I'm gonna pick values that is larger than half and value that is less than half, and check the signs of f prime. So I'm gonna choose 2 and minus 2. And notice here, since our function here is fraction, not all x values are in the domain, so do not pick a value that is not in the domain of x. So for here, our choice is 2 and negative 2. It's in the domain of x. So again, I'm gonna see what are the signs of these value at f prime. So for f prime minus 2, so note that the bottom is squared. That just means the bottom is always positive. So it's gonna be 1 minus 2 and minus 2, gonna 1 plus 4, and that gonna be 5, which is a plus, so positive. And then I'm gonna take x equal to 2, and it's gonna be 1 minus 4, which is minus 3, which is a negative number. So I'm gonna mark that in our number line. So what we notice, we are going from positive slope or positive derivative to a negative derivative. Therefore, from this shape that I just graphed, x equal to half is a local maximum. So again, our function is 1 over x minus multiplied by x minus 1. If we graph that function, we can see clearly where is our local maximum. This is the graph of x. And again, at x equal to half, we will have our local maximum, which is shown here in the graph. You can see it clearly.